Hello, my name is Aurelia, and I'm from Group E, along with my teammates Davin and Farel. And today we're going to present our final report on our rescue delivery system. So let's begin. So first of all, we have the description of the project. We have to make a delivery system consisting of an aerial vehicle and a launcher that can deliver a payload intact to a certain target area. And the vehicle must be able to reach the target area without the area using a launcher while staying intact and keeping that payload also intact. The specifics of the vehicle and the launcher are can be seen in the slide over here. Next one is, these are all our design alternatives. So on the top right, you can see the sources that the pictures that we pull inspiration from, and some prototypes and some designs that we tried out in the process of making this vehicle. So the vehicle, ideally, we would like a design that's based on ease of manufacturing it, the strength of its structure and the aerodynamics of the structure, and the strength of lift versus its vehicle weight. So, and meanwhile, the launcher that will be ideal is a launcher that's very stable. It has strength and rigidity, smoothness, and the measurements will cater to the vehicle, and it will also hopefully be easy to use. Next is the design characteristics and principle. So the ideal vehicle that we want to make for our vehicle is that it's using as light material as possible, and that material will be used to hold the tails and the wings together while attached to the load. Its shape should have smooth edges to reduce the friction. The wings consist of ribs made of pla, and it's 3D printed, with a hole each to attach the carbon boning. The carbon is attached to the main body of the vehicle. And then the launcher should have the strength to launch the vehicle and should minimize the use of human skill.
And just to complete the previous slide, the 3D printed parts or the ribs are made of PLA, which is the filament used for the 3D printer. So it's like the ink of the 3D printer.
Yes, thank you, Hans. So this is our prototyping process. There are several stages to our vehicle making. The first vehicle was using balsa wood, and the flaws were that this was too fragile and there's not enough lift. Second, we tried using wings made of pure PLA, and it turned out it was too heavy and it didn't have enough lift either. The third one is the wing made of a mix of carbon and PLA, and this was our most successful one. It will also be wrapped with oil paper. Yes, it's oil paper, and attached using tape. Now, as for the main body, the prototype was using balsa wood, but after a few test flights, we discovered that it was too fragile, so we replaced that to another final design. And the next is the launcher, prototype and design making, which my teammate Davin will explain further.
Okay, so next up we have the launcher. We have two versions of launcher. Launcher 1, as we can see with the picture above, it is made of square wood and balsa, so it's really sturdy. That's what we wanted on our design. We wanted a sturdy design where if we put a lot of stress, a lot of potential energy, it will not flex or move, and it could be a solid base for our plane. And we did that, so our design did made into reality, and what we wanted it came out. But actually what we wanted was not what we needed. We actually needed something that is accurate and something that is consistent. Our design is strong and bulbous, and it is not consistent, and it is not reliable, and it is way too harsh for the plane. And it's like the plane and the launcher is not built together, so they do not work together nicely. The plane wings would scrape on the rails of the wood, and it would scorch the wings. And so Davin decided that he could make a launcher where he designed and 3D printed it himself. And as we can see on the picture below, this is the launcher 2, which uses a trigger mechanism, and it's fully 3D printed. And with this design, we are able to replicate the same amount of launch force every single time. The only difference or the only factor that would make an error is if the rubber was fatigued or it was already stretched. But everything else, it would give consistent flights for the plane every single time and requires basically no human skill. Right, Devin?
Yeah.
Next one, we have the design modifications and improvements. So from what we've learned from the previous prototypes is that the vehicle, the materials that are used for the vehicle was too fragile. And we can also actually save weight by, instead of making a solid balsa wing or a solid PLA wing, we can use frames and then shape very light paper around that wing to make a hollow one, but also still has a surface instead of a solid wing. And from flight tests, tail fins greatly determined the trajectory, and the tail fins are also very have a propensity for braking. Next, the launcher that parts of the launcher that we must modify is that, again, as Hans already explained before, it has to have minimal friction. The use of the launcher must be more effective, and its force must be catered to the vehicle. Now, this is our final design. So the size of the wingspan of this vehicle is 50 centimeters with 7 centimeters. Vehicle length is 50 centimeters total. The launcher's length is 47 centimeters. The height without the tripod is 8 centimeters. The tail of the vehicle is 18 centimeters, and it's 110 degrees apart. The material is a mix of everything that we've discussed before. The wings are made of paper, PLA, and carbon. The main body is made of carbon, and the tail is made of balsa. Meanwhile, the most of the launcher is made of PLA, and then mixed together with a few like iron, bolt nuts, balsa wood, and rubber. So next is the reflection and the test results. So our vehicle landed in the main target 2 out of 3 launches, and the third launch landed in the buffer, slided and landed in the buffer zone. The chalk is fully intact for 3 out of 3 launches. The vehicle is still fully intact for 3 out of 3 launches, and the launcher is also fully intact 3 out of 3 launches. The lessons learned from making this a vehicle and the launcher is that by minimizing human input, we also minimize human error, by which we mean that by using 3D printers, by using programming like Shaper 3D, and by also making the launcher by only making the human press the trigger to deploy the launcher, we minimize human input, and therefore we minimize human error, and the making of the launcher and the vehicle and everything else is much smoother and much better. The second lesson that we learned is that we must utilize strong yet light materials and designs. For example, previously we tried solid balsa and solid PLA, and that was too heavy. Instead, we could have tried frame and then made this large surface using paper instead of a solid material. And also the main body was using balsa, but instead we discovered carbon was actually lighter than the balsa that we were using. So we should have used carbon instead, as it is also much, much stronger. Possible improvement for our design is to create an actual aiming feature for the launcher, since it still requires skill for aiming from the user, and also devising a better design for the tail fin that won't break during crashes. Anything else to add, Hans, Davin?
If there was anything else to add, I think definitely if we had more time, we would have probably evolved the design better, but for how much time we had, our time was limited due to the balsa version breaking like 3 days before. flight test, but if we had more time, we could probably try to save more weight, so we could make a better rear wing and probably make sure that it doesn't tilt in any way like it did a little bit on the test day. But that's it.
All right, thank you, Hans. And other than that, if there are any missing information, such as the pictures that were required of the vehicle and the launchers, it's the front view, the side view, drawings, etc., etc., they will be presented in the larger video that's in the YouTube link. That's after this presentation. And that's all from Group E. And thank you for listening to this presentation.
Oke guys, jadi pada kali ini kita lagi bikin launchernya. Jadi ini kayunya lagi kita amplas biar pas pengerjaan nggak ada yang kena sebenarnya atau splinter. Terus ini lagi bikin 3D buat launchernya, ya 3D lah kira-kira. Ya kira-kira itu sih progres kita hari ini. Jadi ini udah jadi 3D-nya, kira-kira gitu. Sekarang udah mulai pemotongan kayunya. Ya.
Bunyinya agak serem banget.
Jadi ini kita lagi bikin strukturnya.
Kira aja kan. Jadi ini kita baru selesai pencetakan 3D printing salah satu, ini apa namanya, ribs ya, ribs dari wingnya. Ini filamen yang udah kita beli warna merah, emang buat ini ya khusus ya. Ini udah settingannya semua oleh Suhu. Ini apa nih artinya 56 menit nih?
Si printing time-nya.
Oh jadi bikin ini 56 menit satu ini. Dan kita bikin 6 biji.
6 biji.
Jadi ya 6 kayak ya sekitar 6 jam untuk bikin part sekecil ini aja. Dan rod tengahnya nanti masuk carbon fiber ya. Terus ini masih kotor-kotor gini nanti diapain nih?
Ini bersihin pakai cutter aja.
Dibersihin pakai cutter. Fungsinya buat apa? Biar lebih enteng juga ya sekalian. Sekalian biar lebih clean.
Ngerapiin.
Oh langsung cabut gitu?
Cabut. Bersihin sisanya. Print lagi.
Print lagi. Oh ini udah ada kayak loaded valve-nya gitu ya? Nah. Udah ini sekarang lagi ngeprint?
Ya.
Kok dia nggak gerak?
Ini kan manasin.
Oh manasin dulu, betul. Filamennya biar lebih cair ya?
Iya, biar cair. Kayaknya sih ini juga.
Oke guys, jadi ini sorry, ini penampakan wing kita setengah jadi. Jadi yang ini masih digedein bolongannya. Terus yang satu lagi tadi masih printing. Ini kira-kira bentuk aerofoilnya nanti gini. Terus dibungkus kertas ini. Tuh ya guys, keren ya. Oh rekam doang. Lu yang tangkep. Woi jangan tinggi-tinggi, rendahan dong. Lu jongkok aja. Nah. Ya. 1, 2, 3. Oke. Wih. Mos deh parah. Itu lu tembaknya ke atas gak sih soalnya?
Iya. Wah, rata aja.
Jangan. Oke, sip. 2, 3. Ya. Tadi. Mau gimana nih? Lurus.
Full power sih. Full power.
70% lah, jangan full. Jadi review singkat pesawat kita. Untuk chassis-nya depannya di rounded biar ngebelah udara lebih mudah, dan ini agak besar supaya support wingnya kuat. Kemudian ini wingnya sendiri, ini bentuk aerofoil kita. Bawahnya rata. Ini nggak ada angle of attack sama sekali. Ini rata lah intinya. Terus ini belakangnya scoop gitu ke bawah, nurun ke bawah. Terus ini tipis, seenteng mungkin. Dan kita ada horizontal plane yang rata juga. Siap.
Lu lihat gak?
Goblok.
Bisa. Buat laporan gak susah anjing. Materinya banyak.
Jadi sekarang kita lagi bikin. Ini hari Sabtu by the way. Hari Sabtu tanggal
Gak usah kasih tau tanggalnya.
April. Jam 9 malam. Kita belum punya pesawat sama sekali. Masih desain. Tapi ini kita lagi bikin karbon adaptor ya, karena kita udah kehilangan kepercayaan sama balsa ya. Jadi sekarang kita lagi bikin, ini iteration pertama 9,7 gram estimated. Tapi kan itu keberatan. Jadi kita bikin versi keduanya ini. Untuk wing stay-nya, kita tuh maksudnya Davin ya. Ini udah di 6,7 gram. Jadi kita udah save berapa tuh? Sekitar 30% lebih sih. Kita udah save weight dan kita masih goal kita sekitar 5 gram. Let's see kalau bisa. Oke guys, jadi selain weight saving juga, satu hal yang kita notice itu ini print mode-nya. Jadi ini 3 jam print mode-nya. Dimana waktu kita kan seperti yang sudah disebutkan lumayan mepet. Jadi kita selain weight saving, ini juga time saving dari 3 jam 17 menit ke 2 jam 12 menit. Jadi kita save weight, kita save filament, dan kita save time. Printnya di sebelah. Desain di sini, analisis di sini, print di sebelah. Jadi kita workstation. Ya, Pin? Slice now. Jadi ini Mark 3. Perubahannya adalah kita bikin bagian sini-sininya tuh ada yang tipisnya. Jadi ini ditipisin. Jadi berapa ya? Ditipisin 4 mili ya?
Kenapa?
Ditipisin 4 mili, 2 mili, 2
mili jadi 2 mili.
Oke. Weightnya tadi 675. Widih, 5,5. Iya. Jadi walaupun waktunya cuma kurang 5 menit, tapi kita turun 1,2 gram. Worth it banget sih. Oke. Kayaknya kita mulai cetak kali ini ya. Nanti sekalian nama yang lain apa? Oke guys, jadi proses designing setelah 4 iterasi sudah selesai. Kita sekarang mau masuk ke tahap printing. Jadi ini 3D printernya pertama dibersihin dulu ya, pakai hand sanitizer aja. Alkohol. Fungsinya apa? Biar kita punya barang nggak kena COVID. Bukan?
Nggak gitu bang.
Oh nggak gitu.
Jadi biar dianya lebih nempel sama bednya.
Ya karena biar nggak ada minyak. Kan kita pegang tangan kita tuh kulit kita ada wax. Ada oil. Natural oil biar hilang, biar dia nempel. Terus ini filamennya. Kita punya warna merah sengaja karena merah itu racing. Sesuai dengan pesawat kita ya. Nggak juga lah, biar ada kontras aja. Terus
sama paling murah sih filamennya.
Jangan gitu dong. Ya sebenarnya ini filamen kita juga paling murah. Ada berbagai macam filamen. Kayak ini PLA namanya, tapi ada PLA lightweight, ada PLA compound carbon, ada banyak lah, ada karbon bahkan ada ya. Ini kita yang PLA paling murah biasa karena ya kita work on a constrained budget, even though this. Dan juga harus dipanasin ya. Fungsi dipanasin buat apa bang? Jadi dia
biar nempel juga.
Biar nempel ke sini ya. Jadi ini di set sampai 60 derajat nih ya. Sekarang 26 atau 60 derajat. Terus yang atas ini temperatur nozzle-nya, nozzle ini untuk melelehin PLA-nya tadi. Card remove kita tuh tadi udah masukin filenya, ditaruh di SD card. Ini SD card-nya. Colok. Sorting file, cari PRD. Carbon wing adapter. Tuh. Kenapa tadi kelihatan bang?
Mana sih? Oh iya.
Nah ini harus diupdate bang, tapi santai.
Skip sih.
Terus ini juga kita punya printer speed di 113%. Jadi yang tadi predicted 2 jam 7 menit ya
jadi sejam 50 menit.
Ya kira-kira lebih cepat lah. Sejam 50 menit karena di overclock ya jatuhnya. Oke. Kenapa overclocknya cuma 113%?
Dia tuh nggak auto adjust, jadi emang sama layernya dia nyari yang paling optimal.
Oke.
Soalnya di setnya gue sebenarnya 120%.
Iya, gue ingetnya kemarin 120%.
Oh iya, ganti sendiri sih dia emang. Naikin lagi sih manual.
120%.
Nah,
1 jam 45 menit lebih cepat. Tapi ya harusnya semakin tinggi speed akurasi turun, cuman ya naik 20% mungkin belum terlalu kerasa sih.
Nggak terlalu efek.
Oke, jadi ini nanti kalau dia punya bed temperature udah sampai 60, dia akan mulai ngeprint. Oke, jadi udah jam 00.04 sekarang. Dan oke, udah selesai. Sekarang moment of truth-nya karbonnya muat atau enggak. Ada kemungkinan nggak muat dan
Udah ada.
Oke guys, jadi sedikit kurang besar. Kayak muat tapi friction fit banget ya. Jadi kita mau gedein dikit. Coba ya. Coba. Oke, jadi setelah kita gedein, kita mau coba tes fit. Nah, mantap. Dan ini snack banget ya. Jadi dikasih lem dikit udah pasti nggak gerak.
Udah.
Nah,
Tuh, ya. Rata
bagus. Jadi ini
demonstrasi video demonstrasi nggak? Demonstrasinya